Have you ever tried balancing a book by placing it on your fingertip? If you've tried that before, you would notice that the book would not balance except at a single point. Now, if you place your finger at any other point, the book will topple over and fall. The point where the book balanced on your finger is called the center of gravity. Now, the center of gravity of a body is that imaginary point through which the resultant of the weight of all the particles of that body acts. Every object, irrespective of size, shape, or composition, has a center of gravity. This includes both hollow and solid objects. For a uniform regular body, the center of gravity is usually at its geometric center. A uniform body is simply a body whose density is same throughout the body. So a regular body in this context simply refers to a body with a known geometric shape. So let's run through some examples. Examples include, say, triangles, squares, rectangles, circles, kites, cuboids, rings, cones, cylinders, and spheres. So for a uniform circular plate, its center of gravity is at the center of the circle. For a uniform rod, the center of gravity would be at the midpoint of the length of the rod. For a uniform circular ring, the center of gravity will be in the middle of the ring, at the center of the circle that makes up the ring, even though there is no mass in the middle of the ring. For a uniform rectangular or square plate, the center of gravity is at the intersection of the diagonals of the rectangle or square, which some of you may call the middle of the shape, but it's pretty vague. For a uniform sphere, the center of mass is the center of the sphere. I hope you got the gist. When we know the center of gravity of an object, we can treat that object as though all the mass of that object is concentrated at that point. This is what we call the point mass, and it helps us simplify our analysis of the motion of objects and the forces acting on them. You will see more of these in subsequent lessons. Bye for now.